interview series. Take a load off from your busy workday and listen to the dulcet tunes of our guests, who are all over the cybersecurity landscape. We're going to ask them some hard questions, not going to lie, probably some softballs too. But no matter what, it's going to be a good time. So sit back, pour yourself a nice hot cup of coffee, or something stronger if it's that time of day, and enjoy Coffee Talk with Serge. Welcome, everyone. Thank you for coming to Coffee Talk, the interview series. And today we thought we'd do a person a little closer to home, the incredible, magical Kirsty Paine, who many of you have seen on Coffee Talk over the months. But along with being a fantastic co-host on Coffee Talk, she's also one of the subject matter experts at Splunk that we reach out to for a lot of different issues that we're going to talk about today. I personally find that Kirsty has one of the most fascinating backgrounds that I've met at Splunk. So before we go in, Kirsty, would you like to tell us a little bit about how you got here today? And that's going to provide perhaps some context for the rest of the conversation.
Yeah, thank you. And thanks for having me as a guest. It's always flattering when someone says you've got something interesting to say. So very happy to try and prove everybody wrong today. So my background, I work for Splunk now, of course. I've spent 2 years here now as a field CTO, which is actually really flown by. But before that, I worked for the UK government, which I've referenced in many of our Coffee Talk chats. I worked specifically for the UK National Cyber Security Centre, NCSC. There are many NCSCs now, so I have to be careful to say it's the UK one if you can't tell from my accent. And I worked there for several years. And the last job I had there was I did a lot with big data. I started as a mathematician, so a lot of cryptography, and that was my background, kind of moving up around the organization, doing all the fun maths that there was to do. But my last role there was looking at things that might affect the security of the UK in the next 5 to 10 years. And that's pretty broad. And what's also really interesting is a lot of those things that I was working on are now happening. Right. So I worked on AI, I worked on IoT, I worked on quantum, I worked on a lot of emerging technologies. And we're now starting to see those come into pass. So I'm hoping it keeps me relevant, at least for the next, 3 to 8 years. We'll see how good my predictions were. But yeah, it was a really interesting job. I got to do a lot of cool stuff, traveling around, representing International Technical Forum, meeting really interesting people from industry and people from governments and academia as well. And it was just such a great hive of collaboration around security.
Really fun. For me personally, when we first started talking about quantum at Splunk about a year ago, I actually reached out to you because I had so many questions. I didn't actually know anything about it. I'm incredibly lazy, as you know. And I just said, Kirsty, teach me all the things. And you said, sure, here's like 5 seconds. And I was like, cool, but could you write that down? Because I'm even lazier than that. So you actually wrote up a blog that kind of went over the high level. And we see this now with customers. Like I've referred that quite a bit. And some of the questions we have around quantum is basically like, how do I deal with this? Why is this a threat to me? So Kirsty, with your predictions from 5 years ago and today, how much are people actually impacted by quantum? Should they be absolutely terrified by this? It's going to change their day-to-day jobs. What are your thoughts there? Why should I care about quantum?
It's quite hard to say, isn't it? And again, I'm standing on the shoulders of giants here because we have full-time cryptographers and researchers who, are studying this in universities and go to these participation groups in international standards. But really, the answer is don't panic. I think there's a lot of FUD, and we're very guilty of this in security. And for the last sort of 15 years or something, the estimates have been that quantum is 15 years away. And by quantum, in that context, I mean a quantum computer that is cryptographically relevant. So one that can actually break the internet cryptography that we use today. And that's what people are really worried about. And the problem with this, I wrote it in these blogs in the form of fairy tales, because I think that's very easy to relate to. And when you've got something incredibly complex like lattice under structures, and people are talking about vectors and shortest vector problems and all this, it's very hard to understand. But when you put it in terms of fairy tales, everyone can get involved. So I liken it to Goldilocks' porridge, right? You don't want to be too hot or too cold. You don't want to move too soon or too early with your migration. You want to be just right. And how can you tell that something is just right? The most important thing is to wait for standards. So cryptographic standards, algorithms, primitives that have been worked out, have been tested, have been researched. Never roll your own crypto. I don't know how many years we've been saying that. People still do. Please don't. So it's a nightmare. And then also for those like algorithms to actually be put into protocols, to be put into the things that you're trying to use. There's an ecosystem effect, right? If you're the only person that moves, then you won't have any interoperability. But if you control that ecosystem, if it's an internal thing, one approach that we recommended was looking at having your classical cryptography and then wrapping some quantum cryptography around it, so that whenever the classical stuff is broken, you still have that quantum layer. And this is just an architectural different way of thinking that doesn't involve a wholesale shift. So the answer is don't panic, and just think of Goldilocks as porridge.
I'm very fancy today, and you may have noticed the
You
giant
are.
Washington monument over. No, this is how I dress at 7 in the morning usually. I down dress
Sure.
for the rest of the work. I'm going to be talking to a lot of folks in public sector and the government here, and for me at least, one of the things I've learned from you is really the people who should care or could perhaps have more of a reason to look into quantum is really around people in the government or folks who have cryptography that could be broken by this. Is that really the subsector that you see that people are most validly concerned? I mean, you have a difference between like, hey, I'm a Fortune 5,000 company. I'm Splunk. I'm developing software. I don't necessarily care about quantum, but if I work in the Department of Defense, if I work at the MOD, maybe a little bit more valid. Is that an accurate statement?
Yeah, everyone's cryptography is vulnerable, right? That's the thing. It's more, does it apply to you? So is the data you're protecting now something that you still need to be secret in 15 years? And that more often applies to governments and financial institutions. It applies less to telemetry, right? And so that's really, it's about the data that you're trying to protect for however long you're trying to protect it for. And there's a good equation called Mosca's inequality, where if you work out how long you think it will take for a quantum computer to exist that is cryptographically relevant, and you work out for how long you need your data to be secret, and you work out how long you think it will take to migrate, you can make those things together and you've got this kind of window where you're okay. And it depends what your estimates are and what your data needs to be, how long it needs to be secure for. But that's what the inequality shows you. So it's really helpful because there is no one size fits all. That's why it'd be really poor advice to tell everyone to panic today. It'd be really poor advice to tell, nobody to have a look at this. The most important thing is to be ready, right? So to have your asset inventory fully worked out, to be ready for anything that happens. And of course, it's good security practice as well to have your asset inventory somewhere and
And you go
complete.
over this within the blog series, right? For those of you who want more in depth on quantum, who are interested in this, like I said, everything I know about quantum, I learned from Kirsty, and most of that was then encapsulated in 3 or 4 very easy to read fairy tale-esque blogs. So we'll post those in the show notes. Really recommend that. Something else that I've learned quite a bit from you, Kirsty, is how to influence a nation's IoT policies, which I didn't think I'd find really interesting, but that was something else you've also worked on. And you've really packed quite a bit um, in very few
Yeah,
years.
I did. And people ask me why, and I was like, IoT was only supposed to be 10% of my time, which is just one of the funniest anecdotes I think ever, because of course it consumed a lot more. I can't claim sole credit for this. There was a really good, impressive effort from German BSI government and also UK government, particularly my colleague Jasper Panzer, who worked for what was DCMS and is now DCIT, around creating international standards for IoT security. And it's really interesting because IoT, you could boil the ocean, right? Like at one point, everything was IoT and, everyone was terrified about everything happening. And there were all sorts of attacks, dolls and Bluetooth and all the way to like mass DDoS, mass kind of botnet takeovers, things like this. It was just carnage, right? And it's still not great today. So there's some things that the government, is reluctant to do. And in general, in the UK, we don't love legislation, right? We actually, it's a lot of effort, it's a lot of time, a lot of work.
I
And
mean,
it's
you
not always the most
couldn't be
effective
bothered to
tool.
make a constitution, so this is making sense to me. It's
Oh, we're going to start that. Okay, well, we'll get to that later. I think, but it's interesting. Lots of people think government should, make hard rules about this. They should be doing, and that's not what we love to do. And so we had a few kind of voluntary codes of practice for IoT, and it was very tightly scoped to consumer IoT devices. And that's because, if you take on the whole IoT world, you've got medical IoT, industrial IoT, they all have different threat surfaces, different challenges, different approaches that you need to take. It was really, really tough, actually. So just focusing on consumer IoT and also just the device part, not the cloud and all the other stuff around it, because there's already good practice for that. And so with that tight scope, DCMS put out a voluntary code of practice and a voluntary kind of labeling scheme where they were asking, would you want labeling as industry? And the answer came back a resounding no, because that's putting the burden back on consumers to understand, I'm buying something and I'm supposed to understand what it means that it has TLS 1.2 rather than TLS 1.3. How can I make that judgment as a consumer? So often people talk about food labels, the sort of red, amber, green of food labels. There's a lot of ongoing debate over whether you're health conscious, so you look at the labels, or you become health conscious because you have the label there, and which way that correlates and causates. So we didn't do that as government. We did international standards instead. So I, of course, have to promote ETSI, the European Telecom Standards Institute that published this standard, and it's ETSI EN 303645. I don't know how many times I've said those numbers, but 303645. Go and look it up. It's free, it's open, available to download, and it's 13 key areas that IoT devices need to be secure in. And it goes everything from no default passwords, most basic hygiene possible, up to hardware security and some of the more niche applications. But if you're a manufacturer or a producer, or you're involved at all in the IoT supply chain, it's a really good document to look at. I can highly recommend. It's also well written, short, understandable, not like many technical documents. It's actually had a lot of
Who
review
wrote
and a
this?
lot of
Who wrote this document?
well, I
Oh,
helped. I helped, but it would be so wrong to say that I could even claim. So the way that international standards work is you have a group of people in a room and they discuss, and it's all done by consensus, right? So no one gets a veto, no one gets. You just argue it out until you find an acceptable way of phrasing things. Especially in a European context, you're making sure that it works for native and non-native speakers. So the language is incredibly clear, it's incredibly crisp. We had a lot of industry participants, too many to name actually, but it's all on the ETSI website. And what's really impactful is having sort of 40, 50, 60 participants from consumer groups, from academia, from government, from industry. You get a really well-rounded standard that is usable, that is actually going to be taken on by industry because it's not unrealistic, but it's also setting a high enough bar for governments to get behind it. And this IoT standard has been adopted and promoted by various countries, ranging from India, Australia, Finland has a labeling scheme based on it, Vietnam,
I think they
really too many to mention.
joined that standard before they joined NATO, so we see where their priorities are.
Of course, yeah. I mean, it's a really important problem, the IoT. And of course, the
National
UK,
defense
and
isn't
then
based, but IoT.
yeah, yeah. Well, I mean, and for the EU as well, it's something they've concretely taken up, and now there are IoT certification schemes being worked on by ANISA that are looking at the IoT standard as one of the foundational underpinning parts of that certification. So it's really had such widespread adoption and uptake, which is really heartening to see. There's a test specification that goes with it. It's created this whole ecosystem of implementation and testing, which is exactly what we wanted to stimulate in the IoT. So it's really good. Really cool.
And we kind of just keep coming back to these standards, right? Another one that I learned that you had quite a bit of knowledge of as we started this foray into artificial intelligence was also, your work in AI and kind of the background there. And now, of course, the EU is kind of leading the world in a lot of the standards and policies around the utilization of or AI. And then, of course, NCSE and US CISA have just released some joint little collaborative. I don't know if they're quite standards yet, at least in the U.S., but they're certainly giving people guidelines and vibes, right? That's what we're looking for.
Yeah, so I mean, I worked on standards around securing AI. Again, that was in ETSI, and this group started 4 or 5 years ago. So really interesting because ahead of its time, but perfect now because there are standards that exist today on the technical side. So a lot of the AI conversations are around ethics and philosophies and principles, and that's great. But as a developer, what do I pick up today and do? What can I implement? How can I secure my training data? What should I be actually doing with my environment? And that's exactly what those standards speak to. So it's really cool. And it's a very nice catalogue of the problem statements in AI. And now, of course, that is being looked at because ETSI is one of the 3 EU standardization bodies. That's now a helpful feed in for creating these kind of legislations that are not so removed from technical reality, right? They are giving some ground truth for policymakers, which is really important as well.
Well, this is kind of one of the things we just keep going around here, right? We're talking about these new emerging technologies, but the need to actually have regulations, standards, protocols. And when we start talking about protocols and standards, I start thinking about, the internet, right? And I know that you've also done quite a bit of work around. I seem to remember something with your name on it coming up very recently with an RFC.
Yes.
Yes.
I have RFC 9424, just to put it out there.
Throw it out there. I from the very beginning when you get into computing, when you get into system administration, networking, obviously, you learn about IETF, you learn about RFCs, how they work. But I didn't really understand how the IETF worked until I talked to you, because you were a actual participating member. You were going out to Tokyo, spending long nights working through some of those problems, talking to these groups all over the world, right? Can you talk a little bit about, I found it absolutely fascinating. I had no clue, just this like almost parliamentarian, for those who've ever seen the British, Parliament questions, Prime Minister's questions, it sounds like this. I'm expecting backbenchers to throw up and, as you go through.
I'm loving this because I know many in the IETF would hate any likening to a government institution. They'd be positively
I'm sorry,
appalled.
those sound like backbenchers. There we go.
Okay, well, I'll let them know. Yeah, so
Ooh.
I went to the IETF, which is the Internet Engineering Task Force, and it sounds so cool. It's another standards organization, but task force, yeah.
I'll use it
And it has, yeah, it's very directed. So they design the protocols that make the internet work, right? And this isn't law or policy or regulation, it's technical stuff that then gets adopted by discerning customers like those who are designing 5G, 3GPP and other standards organizations. They can choose the protocols, they can, choose the options and make them work for them. So they have a lot of discerning customers, is how I would say it. I'm not sure that's how they would describe it, but they're basically making these protocols make the internet work. And yes, lots of people have seen an RFC, they've seen the ASCII and the ASCII art, but what goes into that is quite a lot of discussion. There's meetings 3 times a year. They make very sure to go around all the different geographies. So there's usually one in North America, in Asia, and in Europe. So most recently in Prague. Next year it will be in Brisbane, Australia. So really cool. And the meetings are just numbered. So they're on meeting 119. So it's been going for a few decades at this point. And every meeting you get a T-shirt. And the older the T-shirt you can wear, like the cooler you are, like to show you were there back in the day. So my first T-shirt was IETF 101, which was in London. Just went to my local IETF meeting. Wish I'd brought popcorn. It was so entertaining. Maybe I'm just a nerd, but it was really engaging, the discussion. Maybe, but I would encourage people, you can join virtually. You can go in person if it's coming to a city near you. Lots of academia, lots of government there, lots of industry mostly driving those conversations. And so interesting, you see a sort of draft RFC put up. You better have read it beforehand because there's no time in that meeting to go through it. They provide key updates, and then there's a mic stood in the aisle that you queue up behind, and you wait until you're called forward to give your point of view. And it's all chaired by a couple of volunteers. I was the chair for 3 groups by the time I left, and then you have area directors that manage all the programs of work. But there's a security area, and that's the one that I would mostly go to. I'd go to the security groups. So there's a crypto forum group. There's obviously TLS is the one most people have heard of, but IPsec, all the famous protocols, but also some really interesting new cryptography coming out that would have its own group. Things around attestation and tokens for sharing information selectively, like really interesting random things that you would end up finding. And of course, I wrote an RFC on IOCs.
Yeah, I'd love to hear more about that. Like, what was the provenance for deciding to create that? What was the kind of thought process here? Like, you saw it, and I know you worked, I'm saying you, but there's a group of people who you collaborated with. I believe your name is first and then et al. But how does this actually go through? What did you, like I said, you saw a problem, you're like, we need to solve this for the entire world, and then let's write this up, make some ASCII art? Or did it start with, I want to create the pyramid of Payne with an E, and somehow work backwards into an RFC where you're utilizing it?
Full credit to David Bianco, but so many people ask me if I invented the pyramid of Payne, right? I was like, I wish I'd be a billionaire. No, so I mean, a bit of both. So I went to this organization. It has so many interesting engineers, right? But they're mostly engineers from these big tech companies, and almost none are what I would call cybersecurity experts. You've got cryptographers and you've got ComSec people, but they didn't have the breadth of what I would call operational security, cybersecurity, an idea of how an organization would be attacked, right? What things they're looking for. And for some of them, it's genuinely surprising that anyone looked at internet protocols to help them find out what was going on. The idea that they would look at DNS. They're
Really?
like, really? Yeah. And I, so I think most people watching this will go, they didn't know that the DNS logs were important, right, to an average analyst. And I've not met an analyst yet that has not been incredibly surprised by that, right? Like, it's bread and butter. So that really shows the gap of knowledge between, and like maybe many cybersecurity professionals don't know what's happening in the IETF, they just didn't really know what was going on in an organizational SOC, right? So I
So,
had a few ideas like, how can we bring this knowledge? Yeah, go.
well, I was just going to say, so this is like literally you're explaining the confusion that every cybersecurity professional had when like DNS over HTTPS got released. And like, isn't this a great step forward for privacy? And we're like, you've just screwed us. Like, this was our
Yeah.
primary method for detection for 20 years. Like, first GDPR, now this. Like, what's left? Are they going to start encrypting email? Like, is PGP
Yeah.
finally going to work?
Yeah.
yeah, now
So
a lot
DoE,
more, right?
DNS. Exactly. So DNS over HTTPS, or DoE as it was often called. And I know a few people made jokes about that, like, yeah, like, DoE, you've just taken away all of my helpful security information.
Yeah.
Thanks. Exactly that. I was explaining that, and there was real disbelief, what proportion of incidents is this used in? How many analysts? And I'm just like, it's just, I would say near 100%. Like,
Yeah.
I don't have any evidence for this, but it's kind of like asking,
I don't think I've ever worked an incident where we don't at least look at DNS, right? Like, that is usually my first network traffic. No matter what, at some point I'm going to look at DNS traffic.
Right. And there was just disbelief, right? There was just like, you're from the government, you just want this data. Da, da. I was like, no, well, yeah, like when we're investigating an incident, we also use DNS to find like internally, but just ask everyone. But the problem was there wasn't a big community of cybersecurity experts in IETF, right? And they didn't really talk. There wasn't enough collaboration. So I was like, this is crazy. So I wrote a draft RFC, the idea being I could get a lot of people to collaborate, give feedback on it. And that would be at least an informational document that could explain things like, network artifacts that defenders were using and really needed today to be able to crucially actually resolve an incident or understand what was going on. And just flag, because there was a lack of knowledge that these things were being used. And it wasn't just DNS logs. It was, like you might pivot on a TLS certificate. So they're now encrypted in TLS 1.3. And the idea that anyone would be using TLS certificates, again, no idea. Like, really surprising to a lot of people there.
So would you say
I
this?
found that very shocking.
No, I mean, those are my two favorite pivoting points, right? DNS and then TLS certificates. Like, years ago, I wrote a whole presentation with my good friend Dave Harold on pivoting off of TLS certificates for PowerShell Empire. Like, they do default TLS certificates, and it's like, oh, you go on to Census, you can scan the internet, mass scan, pull down literally, and quickly find every instance where PowerShell Empire was utilizing this default TLS cert. It was super easy, but then that all kind of went away.
Right.
So
it shows the importance of going to these standards bodies, because I was there putting this viewpoint forward. It's very unpopular coming from the government. Would have loved to have a lot of industry folks there putting across their viewpoint, and just having a bit of a diversity there, because you lose, when this is rolled out as a standard, you lose that optionality. And it was forcing a lot of organizations into this uncomfortable position of, do we upgrade to the latest TLS 1.3 protocol? It has a lot of security benefits. It removes a lot of, really creaky, terrible cryptography, but I'm going to lose this visibility that's crucial for me today. So do I wait? Do I hope that something else comes along? Do I find new techniques? And you're just forced in this position where there hasn't been that great adoption of TLS 1.3, and in part is driven by this. So it's been really interesting to try and bring that viewpoint, but that's why I wrote the RFC 9424, stealing the pyramid of Payne from David Bianco. He's probably credited, but I feel like I always put an E on it.
But you did put an E, yeah. So it was awkward.
Yeah.
I love this. So I didn't realize that the RFC almost, I'm not going to say legitimizes, but it puts it in a parlance, it's in a lingua franca for this group to be able to understand this, this is a specific subject matter expertise, SME who's writing this up, who speaks the language as we do, who understands the context of the problems we're trying to solve. And now it's in an RFC. So it's official, it's formal, it has to be discussed. And now we can have open dialogue within these, long lines of people who keep saying dope all the time. So
exactly. And it can be referenced, and lots of things like that are very important, that you have this precedent where you can say, as stated here, and you don't have to keep rehashing the argument, like, no, DNS is used, right? It's just there. So it's kind of been adopted. It's had the consensus to go through. It took some time. I think it took a few years for that to go through.
Right? I remember you.
Yeah. That's right. Yeah. So I was the lead draft author.
The draft, exactly. Like, what's the process here? So you write up the white paper, you put it into draft, you go to one of these IETF congresses or whatever it be, parliaments, and kind of start talking about it and hearing everyone's
Yeah.
discussions and building consensus to get it approved?
Yeah, so you first you write your draft and you put it forward, and you might get some comments on mailing lists and things like that, and hopefully you get some time to present it at the meeting. Just talk through what it is, what it isn't, what it's aiming to do, what's in and out of scope, and then you ask. It depends. You can go through a dispatch route where if you're not sure what should happen to it, you can ask the wisdom of the IETF which group does this best sit in. They have like 100 and something groups for
Wow.
all different places that your work could go. So it's pretty hard for an outsider to know where it should go. So you find some friendly people, ask them, take it to one of these groups. They can help direct the work to somewhere. Then in that group, they have a literal hum to adopt it. So yeah, they just hum for this, and you hear this kind of ethereal
Oh, and a literal hum.
noise, a literal
Mm,
hum. Yeah, it was hard during virtual meetings, but the hum is a very proud like artifact of the IETF
wow.
because they don't vote, they hum. It's rough consensus. So the idea is if you can't hear an audible difference in the hums, then there must not be enough one way or the other, right? You have to hear a very loud or very quiet hum.
I
It's
I
it's
literally don't know
it's
if you're
niche.
joking right now. Like, I'm going to be looking this up and then find out
No,
they
it's for
actually do
real.
like flat, like poetry snapping of fingers. That's really how they do it. That's the
No, it's for real. Yeah, it's for real. That's how the internet's decided. It's on hums. Um,
I thought it was going to be
Moving
vibes,
on,
but it
because
turns out it's hums.
it's literal hums, yeah. And so then hopefully the document gets adopted by that group, and then it goes through several rounds of feedback. The group adopting it just means this is a reasonable size problem, and we think it's interesting enough to work on, and it's in our group's remit. And then you have several more rounds of feedback, lots of comments. At some point, you might say, okay, I think it's ready for the working group last call. Then it goes up to area directors who get a review of it. And then the whole IETF can at that point also veto it or send it back with some different changes to be made. And then once it's gone through all of these rounds of feedback and clearing hurdles, then it can go in the publication queue. And that itself takes a few months as well.
Wow,
And then you have
that
an
is
RFC. That's how RFCs are born.
so. Yeah, I thought they were storks, but it turns out it's humming.
No, yeah, and the ASCII art really adds to the picture there. It's very important. So yeah, some documents move very quickly, some move very slowly. I think 3 years was about average. Quite proud of that actually. It's like
So
getting it through from.
other than your own RFC, do you have a favorite RFC that you just like? Oh, this Chef's kiss.
Okay, well, there's a few. There's like they have ones that they publish on April 1st, which is like very enjoyable. So every year there's like a joke RFC, and there's one that talks about the history of ASCII art, which is very enjoyable. But in terms of numbers, I mean, you've got the classics, right? You've got all the TLS ones. They're probably my favorites because they're such a labor of love. I think 21 drafts in the end for the TLS 1.3 before it went off to this last call, and then a few more after that. I don't know, quite a lot of cryptography ones I quite enjoy. I'm a bit weird though, Ryan. So
Really,
I don't know if
really,
this would actually
yeah.
be.
What
Yeah,
was that about being a nerd? I didn't hear you.
I really enjoy them. Like they're very clear, they're very well laid out. I like how you always have the client on one side and the server on the other. It's very predictable. It's nice. Must read.
Well, must read RFC. I look forward to that blog coming out soon. The top 10 RFCs by Kirsty Paine. Coming shortly will be.
I think probably no one would get through. I mean, some of them are very long, right? So my favorite ones are the ones that are short, but that does not
Short,
include
clear,
TLS
concise.
1.3. Exactly. But that's the thing with standards. It has to be non-flowery language. It has to be very, very clear, and because people have to implement based on that. And that's where you can get errors. That's where you can get insecurities as well. So it's really
I'm
important to
wrong
make
with
sure
the
it is.
SMTP because SMTP RFC is it's a hot mess. Like the whole protocol is a hot mess, right? It's like, what do you need to get an email? You're like, well, a 2. There you go. Have fun. Off you go.
It's pretty rough. So I think the quality has got really good over time. The weird thing about RFCs is they can't be revised. They can only be obsoleted,
Really?
and so you don't update that RFC. Very important to look at the top. There's always an errata on the RFC. So if you're thinking that's the absolute latest, it's not updated in the text. And if something has enough erratas, then errata is already the plural. If it has enough errors, then it will be reopened and republished.
Wow.
True. Yeah.
I've learned so much
There you
about
go.
RFC. I have no clue. The humming blows my mind. The method is fascinating.
RFC trivia.
RFC trivia, yeah, that's a pub quiz right there. very boring pub
Yeah.
quiz, but one you would crush.
I
Absolutely.
think actually it could go down really well at one of these meetings. You have like 1,200 attendees, so I'm sure you could get a few groups together from
Oh
that,
yeah,
a few
that'd
pub
be
quiz.
solid.
Yeah,
We'll
yeah,
just do it. That'll
fantastic.
be a side business. Find, Brisbane, Simon O'Brien, James Hodgkinson from my team. You have your tasking, set up that the pub trivia for IETF nerds. You're going to make a killing. It works
Yeah,
really well.
sure. It's a new
Um,
Splunk work stream. That sounds great. I'm sure the IETF would love it. Yeah. I mean, they do have a lot of good initiatives, things like mentoring and stuff like that as well around the sides. Like, it's not just all about the protocols, but so I think there is room for a pub quiz, something like
there we
that
go.
we could add in. Yeah, why not?
Well, with that, we're just about at time. We could keep talking for you have such a background. It's so fascinating. So I'm sure we'll have you on again in the future to talk more about some of these deep dives, especially around IoT. We didn't even get into incentivization. There's so much more, but I do want to keep it a little tight here. So I'm going to say farewell. Thank you so much, Kirsty. As always,
Thank
we
you.
turn to you quite often at Splunk for these thorny issues around math, cryptography, IoT, and standards. So thanks for sharing a bit of what you know today.
Thank you. Yeah, no, it's been great. And if I can just encourage everyone, get involved in standards because it's where the new technology is. It's like the cool place to be.
I know Drew Church, if he's watching, he will be very interested in that. So, okay. Thank you very much, Christy, and we'll
Thanks so much, Ryan.
talk to everyone soon.